Let's do another CSCS sorting and searching problem. Traffic lights. So what's going on here? We have distributed length x, and we're going to add traffic lights one at a time, and we're supposed to calculate the length of the longest area without traffic lights. I think this explanation is very bad. Let me try and explain the problem myself. So we have some interval, length x, and we're making cuts in the interval. And after every cut, we want to know what is the longest contiguous piece left, right? It's not cut. So maybe it's here right now, but then maybe we cut it in half, and now this is the longest piece, and we're supposed to report the length every time. And we cut it here, and now, I don't know, this is the longest piece, this is the longest piece, still the longest piece, etc. Okay, so how do we do this? And there's 200,000 cuts, all at different positions, and up to, the length is up to a billion. So what we're going to do is use set again, two sets actually. One of them is going to store all of the different lengths that we have, and so we can quickly extract the maximum out of that. And the other one is going to store the positions. So the idea is whenever we make a new cut, let's say here, we find the two positions that bracket it, right? And think of it, initially there's cuts at 0 and x, so there's always two positions, the left and the right. And so to make a cut, you add a new cut position, you remove this length, and then you add this length and this length. And if you have sets, all of these steps are log n time, and so the whole thing is n log n. So let's do it. So it's x and n. So these are going to be the lengths of the intervals. And so this has to be a multiset, right? So you could have multiple intervals of the same length, right? You might chop up a bunch of things of length 1. And because all the positions are distinct, like the x values, so the positions are going to be cut, this can actually just be a set. So we make our n cuts. And so now we want to find the two coordinates that we made the cut around. So we can use upper bound. Right, so this finds the greater thing, the thing to the right, and minus just traverses the set. So this takes us to the thing before that. Right, so we want to find the thing to the right and the thing to the left. The thing to the left is just the thing immediately before the thing to the right. So this gives us before, and this gives us the value at that position. So record the value of the thing to the right, step 1 to the left, record the value of the thing to the left. So now we can do so this larger interval is gone, so it doesn't count for the length anymore, so we delete it. And then we can insert the two new lengths that are formed. Right, when you cut, this interval goes away and you get this one and this one. And we can also insert the new position, right, because this might be, sort of the endpoint of a cut in the future. And we're supposed to print out the largest value in the set. So the set is sorted from low to high. So our begin, just like reverse begin, gives you, it's just an iterator to the end of the set, which is the largest element. And so star of an iterator gives you the value of that iterator. So this gives us the largest element in our multiset. And that's it, actually. Iris stream set. Don't have to be vector. So let's do uppercase X. Five, three, three. Oh. Suppose they're supposed to all be on one line. Cool. Okay. So that's the problem. This one was kind of, I guess, conceptually straightforward. Right? We're literally just doing what they tell us to do. Just every time we get a new cut or traffic light, I guess, we just cut that interval into two pieces and keep track of the lengths of all of the intervals. It's going to be like n plus one of them at the end. And we just look up the biggest interval every time. And we just figure out the adjacent traffic lights or adjacent cuts to a new cut, and delete the old length and add the two new lengths, and also add this to our list. And so like this is log n time, this is log n time, this is log n time. Almost all of these multi-set operations are log n, but that's fine. The whole thing is n log n. I guess we're running in just around a second. Okay, so we were pretty close to the time limit there. Anyway, that's the call.